This video is just going to be a quick application of how we can use factoring to sort of help us solve equations. So an example is working with area. You'll often have area examples that work really well for factoring. And the reason is this. Remember, factoring is just two things multiplied. And again, area of a rectangle or a square, obviously length times width is a very multiplying, a product kind of an idea. So let's take a look at this example real quick here. You are designing a banner for your school football game. You want the shaded region, and that's the region to the right here, or sorry, the left. You want this region to contain your school's initials. So maybe, SHS here, right? But we're going to have the flag portion, right? The right portion contain the school shield, right? We want this thing to be sort of containing our school shield here. Well, the idea is we know that the actual area of the flag, right, the fabric of the flag is going to be 117 square inches of fabric. So the area of the figure needs to equal out to 117 square inches. Well, we know that W times 2 is the area of the shaded region. So let's just call that 2W. And if we add that to the area of the shield region, well, the area of the shield region would be W times our W plus 2, right? So we're going to have to do a little distributing. And we know that, again, those two areas, right, area 1 and area 2, right? This is area 1, this is area 2. We know those two regions need to add up to 117 square inches. Well, in order to solve this, let's go ahead and clean up that left side a little bit. 2W plus, again, we have to do a little distributing. W times W would be W squared. And 2W again equals 117. And in that case, we've got a W squared there, which means I'm thinking, let's get this thing equal to 0. Because the best way to solve, or one of the easier ways to solve a quadratic equation or a polynomial with a W squared in it, is to get it equal to 0 and factor. So we've got W squared. Notice we had 2W plus 2W is 4W. And I'm going to go ahead and subtract that 117 over to the left side so that on the right, if I subtract 117, I'll have 0 over here on the right. In that case, we want to look for a couple of factors. What's going to multiply to 117 that's going to add to positive 4? Well, let's go ahead and get our calculator out here. Okay? And I'm going to kind of play around with that a little bit. What's going to multiply to 117? Well, the easiest way to figure that out is let's divide 117 by some numbers. Obviously, we can divide by a 1, but again, if it's going to add to 4, our two numbers are going to have to be a little closer together than that, right? Because I already know in order to multiply to a negative, I'm going to need a negative and a positive, which means when I go to add them together, it's just like subtracting, right? I'm going to add two numbers, the larger of which needs to stay positive, right? So that when I subtract off or add that negative number to it, again, I have a difference essentially of 4. Well, 117, let's just start by dividing by 3, how about? So if we had a 3 and a 39, well, if one of those was negative, our difference would be 36. We're going to need something larger, right, than 3, but less than 39. Our two numbers need to be closer together than 3 and 39, right? So 117, let's try divided by 6. Well, it didn't go in there evenly, right? And I should have known that because 2 isn't going to go into 117. Even numbers aren't really going to help us. But I do know that, hey, the difference between them is much closer, but it's still 13. That's still too large. We only want a difference of 4. So again, I need to go bigger than 6, but not even numbers. I need something that's going to go into 117. Well, if 3 worked, maybe 9 will work. And it turns out that 13 and 9 are exactly 4 units apart. So I think we just found our winner, right? We've got 13 and 9. And if the 13 is positive and the 9 is negative, then they'll add to a positive 4. So W plus 13 and W minus 9 would be our two good factors. In that case, w plus 13 could equal 0, or w minus 9 could equal 0, and w could be negative 13 or positive 9. Right? I would subtract 13 to the right, I would add 9 to the right, and I get my two answers. Well, because width can't be a negative length, right, or a negative measurement, I would say that negative 13 is what we call extraneous. It's not really going to work. But positive 9, right, if w equals 9 inches, right, and they just asked us for the width, if the width were 9 inches, I believe that we would get the correct area, and we found our answer. A couple of things to remember about that problem. Number one, make sure you set up the problem correctly. If you're adding a couple of areas, make sure you add those areas together and simplify, right, a little bit. And if you see a variable squared, x squared, w squared, whatever squared it might be, solve your equation so that you're equal to 0. If you're equal to 0, that'll give you the opportunity to factor, split those two factors because we're equal to 0, and solve. I hope that helps you, again, working out those word problems and or any problem where essentially you have a squared variable and you're not equal to 0. Solve for 0, factor, split, and solve. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.